Good evening to everyone. In this video, we are going to deal with the interference of light. And in the earlier classes, we have come across light phenomena like reflection, diffraction, dispersion. And in the UG level, we may also know about the interference pattern, and you come across these interference patterns in the nature also. And in this video, we are going to cover the principle of superposition, Young's double slit experiment, and then conditions for sustainable interference patterns. So let us go through one by one. Right, in this figure, if you see this figure is a representation of interference pattern that is formed on a water body here. So then in this water body interference, what we understand is whenever a disturbance is created in the water or what we are taking, then some light waves are formed. So here to understand the particular interference phenomena, we need to know the principle of superposition here. So what is the principle of superposition? Here we have discussed here the resultant when several light waves coincide at the same place in time, which is simply algebraic sum of the individual displacements of the waves and which are having appropriate phase. So to understand the principle of linear superposition, we have a diagram here. Two waves are, yes, let me show you that. So here we have a number of light waves here. So to have that light wave here, 1 and 2, those two are in the same direction. Here they are in opposite side. So here the resultant is more as compared with the second one, resultant is less. So this type of interference pattern, in the first case this is known as constructive interference, and in this case this is called as destructive interference. And we may come across this in destructive and constructive both interference patterns in the Young's double slit experiment also. Okay, so let us see what is that Young's double slit experiment. So the first thing to learn about interference pattern, the first experiment which demonstrated the phenomena of interference here is the Young's double slit experiment, what we see in the picture. So in particular we have here a light source. Right, here a light source is here, S0 is here, and then here we have wavefronts coming out of this particular source, primary source we say, and these wavefront incident on the secondary sources, which are two slits here. So you can observe this S2 here, and then we have S1 here, two slits are there. So these two slits acts as two secondary sources, giving rise to the different wavefronts which are coming out of this S1 and S2. So the wavefronts coming out of these S1 and S2 will overlap one another, giving rise to constructive interference and destructive interference. So if you see this particular pattern, that is we are having here the maximum and minimum here. That is, the maximum indicates the maximum intensity of light here, and the minimum indicates, that is, in between these two maximas we have a minimum here, and that is indicating the destructive interference. So remember one thing, whenever there is a maximum interference of light, it represents a bright condition, and whenever there is a minimum intensity of light, it represents this dark what we say destructive interference of light. So in this way, consecutive dark and bright bands are formed here. So, and next if you deal with the conditions, that is conditions required for a sustainable interference pattern, then they are here. Yes, let me show you. Right. So conditions, what are the required ones? Conditions required for the sustainable interference pattern, that means to get a required contrast between the maxima and minima, what we are getting here is, first one is the two sources should emit frequencies. The two sources should have to emit the waves of same wavelength or frequency, and the two sources should have constant but not equal frequencies. Of course, the resultant displacement at any point will vary with the time, and no sustainable interference pattern is formed here. So if you observe, whatever the maximum condition is there, whatever the minimum condition is there here, and if you check this, right, so if you check this figure, what we can observe, two sources having waves of same wavelength or frequency. And the second point here, the conditions for sustainable interference is sources must be such that they should emit waves in the same phase. That is the required condition, which is coherence condition. And of course, the two sources must be very close to each other, so that the path difference between any two rays from the two sources and which are to meet at a point must be small. So the three conditions which are satisfying the condition for coherence. And the fourth one is the amplitudes of the two sources must be equal. So here the amplitude of this particular waves which are emitting from these two sources, that is two secondary sources, must be equal, and these two sources which are S2 and S1 must be narrow sources, and they are not to be broad. So that's what the conditions for interference of light. So I think you understood, and we need to check once through it. Okay.